Welcome back, students. This is Meghasham Raju, Engineering College Bikaner, Assistant Professor, Mechanical Department. In the previous class, we have seen what are the comparators and how they differ with respect to a linear measurement. So now, let us discuss what are the functions you require for the comparator. So generally, a comparator should be an high degree of accuracy and precision. So whatever, if you compare the comparators with the linear measuring instruments like vernier caliper, micrometer, the comparators are much more better. They are having a high degree of accuracy and precision. Like in direct measurement, the direct measurement is nothing but linear measurement. We will be the precision is depending upon the least count of the scale and how you are measuring the job measurements. In the similar way, in comparison measurement, the precision is depends upon the least count of the standard units and how you are comparing with the standard units. Now coming to the accuracy, in linear measurements like vernier caliper, the accuracy depends upon the geometry. Like mostly it is a form of a distance displacement. But in case of the comparators, this is an interchange method. Here you can see the interchange method in comparators and distance displacement method in linear measuring devices called vernier caliper and micrometers. And moreover, the scale should be whatever the scale you are using in comparator, it should be linear and should be having a wide range of measurement. Whichever comparator you take, either it is a mechanical comparator, pneumatic, electrical, electronic, the amplification signal should be of linear. And moreover, the amplification signal is linear in the sense a measuring device should have a limited amplification. If you just compare the mechanical comparators, the mechanical comparator amplification will be happening with the links. It doesn't mean that you should have more links. It should be restricted with your application and your requirement. In the similar way, in electrical comparator or electronic comparator, you will be using an op-amps as an amplification. It doesn't mean that you will be using more op-amps so that you will get an accurate result. It's not like that. Whatever is your application, you should choose your op-amps accordingly. Fine. So you have to compromise yourself with an accuracy and the cost. And other factors are nothing but graduations, dial contrast and parallax. I have already discussed what is the importance of the parallax. While reading, you should never make any mistake. And you should consider the temperature effects for the comparators. For example, in summer, the metals will be expanding. So you have to allow the tolerance for the expansion also. In the opposite way, in winter, the metals will contract. In similar way, you have to allow for the tolerance. Finally, the comparator should be versatile. Versatile in the sense, it should work in any type of climate. It should have provision to select different ring attachments and other flexible means so that it can help put to various applications. So now students, let us discuss the type of the comparators. As we know that the comparators are of different types. They can be mechanical, optical, electrical, electronics and pneumatics, and other which are not extensively used in applications, they are projection comparators and multi-check comparators. Based upon your requirement, application and the economic what you are having, you can choose the comparator which you want. Coming to a famous comparator, mechanical comparator, which is having a very long history. They are simple and cost effective, and if you compare with the other comparators, the learning of that means how to use that comparator will be easier when you compare with an other electrical or electronic or pneumatic comparators. So in that, the most important in every industry, these comparator, which is nothing but a dial comparator, will be used. So the simple dial comparator will be having a dial. It is having a dial and a dust cap, not to enter the dust into the gauge. Then the bezel cap, this is used to lock the contact point, and revolutional counter, these are the dial graduations it is having, and this indicating handle which will be working on rack and pinion mechanism, this will be calling it as a stem, and the part which is between the contact point and the stem is nothing but a spindle, and this mounting lug is used to attach to other instruments. So now this dial indicator is mainly used to compare workpiece against a master. So initially we'll be having one masterpiece, then we will be connecting this dial indicator and make a 0 over this dial indicator, then again we'll connect the workpiece and we will compare the results and how much deviation with the masterpiece is noted down. So as I said, the contact point is first set against the master and the dial scale is set to 0 by rotating the bezel. Now the masterpiece is removed and the workpiece is set below the contact point. The difference in dimension between the master and the workpiece can directly be read on the dial scale. That's what. So now, dial gauges mainly in industries, they will be used to check the concentric of the circle. I'll be discussing in the next clip what is this concentric circle. Along with the concentric circle, they can also be used in an bore gauges, depth gauges and vibrometers. And this contact point of this dial indicator can be changed, either it can be a round one or it can be a flat one. Generally the round one and the flat one are generally used in an industry, and this stem holds the contact point. The bezel clamp enables locking of the dial after setting the scale to 0. Yeah, this bezel clamp is used to lock the dial after setting it to 0. In the sense, that's what I have told in the previous slide. Initially we will be taking one masterpiece and you can rotate this dial. This dial will be rotated using a rack and pinion and make this as a 0 with the masterpiece. Then you will be keeping the workpiece and you will see how much deviation is happening. After keeping the masterpiece, you need to lock the 0 with bezel clamp. Now the least count of this dial indicator varies from 0.01 to 0.05. Even there are dial indicators which are still having a higher resolution 0.001, but now we'll be sticking up to a less count of 0.001, sorry. And the range varies from 5 to 25 mm. There are actually two types of dial indicators, which are continuous and balanced. In continuous, this will be rotating in clockwise direction, and here the revolution counter will be rotating in anti-clockwise direction. And in balanced, if you see this figure, it will be having readings on either side. Either it can be in plus side or minus side. Based upon your application, it is used. We'll be calling it as a bilateral tolerance. Now I'll show one diagram. I'll show one clip here. So this is where the contact point will be like this, and this type of dial gauge is nothing but plunger type, and this is nothing but an lever type. That's what I have told you. This is an continuous and this is an balanced type. So this can also be called as plunger type and lever type. Okay, and this is what the bezel, you'll be keeping it to an 0, and here as it can move up and down, plunger, that is the reason it is called as plunger type. This is the contact point, and this is the dial, and this is the dust cap, and this is the revolution meter. Anti-clockwise this will be rotating, and this will rotate in clockwise direction. And this, whether it can rotate based upon this movement forward or backward, clockwise, anti-clockwise will be moved. So the application of this dial gauge is generally checking in concentric of the circles, like you will be measuring the curvature. So like this. So you will be connecting the dial gauge here, and this will, and set it to 0, making it as a masterpiece. Then you will rotate this disc. By rotating the disc, if there is variation in the curvature, it will be shown here. If it is a small variation, it can be ignored. If it is having a huge variation, then this piece will be rejected. So guys, this is the application of the dial gauge. For tomorrow class, I will be discussing about LVDT, that is electronic comparator, electrical comparator, then electronics, then pneumatic comparator, and different types of mechanical comparator, optical mechanical comparator. I will be giving the notes, and the rest part of the third chapter I will be providing through PDF. Then day after tomorrow I will be discussing directly the fourth unit. Thank you.